Welcome to another episode of The Wormhole. I am so absolutely excited about our guest today. He's joining us all the way from Arizona, and it is none other than Professor Chris Impey. Hello, Chris. How are you?
Hello. It's good to see you again. I'm doing well.
Fantastic. So, well, Professor Impey is very well known, but for those of you that are not too familiar, who is Chris Impey? Chris Impey is a University Distinguished Professor of Astronomy at the University of Arizona. He has 210 refereed publications on observational cosmology, galaxies, and quasars, and his research has been supported by $20 million in NASA and NSF grants. He has won 11 teaching awards and has taught 3 online classes with over 350,000 persons enrolled. Yes, you heard me correct. And 5 million minutes of video lectures watched. Chris Impey is a past vice president of the American Astronomical Society, and he has won its Career Education Prize. He's also been NSF Distinguished Teaching Scholar, Carnegie's Council's Arizona Professor of the Year, and a Howard Hughes Medical Institute professor. He has written 80 popular articles on cosmology, astrobiology, and education. 2 textbooks, one which I use with my own students, a novel called Shadow World, and 9 popular science books. The Living Cosmos, How It Ends, Talking About Life, How It Began, Dreams of Other Worlds, Humble Before the Void, Beyond the Future of Space Travel. Well, that one's sitting here, right here on my desk. Einstein's Monsters, The Life and Times of Black Holes, and an upcoming book on exoplanets, Worlds Without End. So I can't wait to have a chat with Professor Impey and hear how does he even manage to get so much done in one lifetime. So welcome once again, Chris. How are you?
I'm great. I mean, to be on a show called The Wormhole, I'm looking forward to the whole thing and ending up in a new piece of space-time at the end.
Oh, that's fantastic. As a matter of fact, the concept for this series really started over COVID and I realized I could connect with colleagues through space and time in this mode. So Chris, I'm going to get started in your childhood because it always fascinates me if there were childhood influences that brings us to where we are later on in life. So were there defining moments in your childhood that led you to this path of becoming an astronomer?
Actually, not my early childhood. So I grew up in Britain, in London and New York, some shuttling backwards and forwards. So I grew up in cities. I grew up in places that didn't really have starry skies or night skies, especially Britain, very cloudy, wet country that's not good for astronomy generally. So astronomers are sort of formed in 2 ways. They have that night sky experience or get a small telescope when they're a kid, and then they trade up for bigger ones and then think, I can do this with my life. Or in my case, I got into it through physics. So physics is the gateway drug for astronomy for many people. It's how you do your bachelor's there and then go into astronomy. So I was interested in astronomy, but I was also interested in high energy physics and just physics in general. So that was, as a student, as a high school student and college student, that was my interest. I actually would say that the hook for astronomy didn't really come till first year in grad school. So I was happy to choose astronomy to go to graduate school in Edinburgh, actually. But the thing that told me, wow, this is the right decision, I've made this choice, and the experience of a sky that I never really got when I was a kid happened in the first year in grad school. I went to observed in Hawaii and in Chile for the first time, both places. I also learned that you could be in grad school on a very impoverished salary, and the government would pay you to go and use telescopes in other parts of the world. And I thought, oh, that's a good deal. So in Hawaii, I had that incredible experience of going up Mauna Kea for the first time. And, and that was an extraordinary sky. Actually, it was I will call it the best drug-free drug experience I've ever had. Because you may or may not know, if you go to Mauna Kea, 14,000 feet, 4,000 meters, you're oxygen starved. Your rods in your eyes don't work very well. So the night sky at the summit, it doesn't look very good. It's all fuzzy and indistinct. At base camp, 9,000 feet, it looks good. But the people who've been there before, and the first time I was told this and got to do it in the summer, you can sit outside and just get a chair, familiarize yourself with the night sky, and then you can take an oxygen canister, because all the telescopes have oxygen in case of problems. And you just stare at the sky that you've become familiar with and dark adapted, and take a big hit of the oxygen, and the night sky just goes woof, it just lights up. You see double the number of stars. So I thought, oh wow, this is great. So that was in Hawaii. And then in Chile was a different thing. The sky is so spectacular. The southern sky, the Milky Way, you know, the star clusters, the Magellanic Clouds, they're just things you can't see in the north. So it's an amazing sky, and it's different. But there I had the wow moment, because I was on my way to the telescope, nervous, anxious that I took everything with me. And I was walking up the path, trying to get dark adapted so I didn't have to use a flashlight or anything. And I paused for a moment with the folder in my hand that I had on my stuff, my observing lists and so on. And I suddenly noticed that the folder was casting a shadow on the ground. There was no moon. It was starlight. And this folder was casting a shadow. And I looked up, and that was it. It was like, oh my God, I have never seen a night sky that dark, that bright, of stars and everything. And so, you know, those two experiences, first year grad school, said, yeah, this is the right thing for me.
Okay, that was the path for you. Oh my gosh, I can't imagine. I mean, I myself have never been able to see anything by shadow by starlight. I mean, at best, maybe the full moon. That must have been actually really, really stunning. So the visual drew you in. That's fantastic. So Chris, even long before we met, and as you know, we met in Trinidad some time back, I was always following your work, and you've been quite a hero for me. So you going through your journey in astronomy and all the book writing and everything that you've done, have you had mentors who have inspired you?
Yeah, yes, absolutely. I don't think any of us can follow, you know, what isn't always an easy or obvious path without having role models or mentors. And I've had various people along the way. I mean, at school, it's many schools I went to, I didn't really have actually great science teachers, it turns out, but I had really great English teachers. So I learned how to value writing and sort of try and get good at it. I had history teachers, and I still appreciate, you know, my newest MOOC is on the history and philosophy of astronomy. So I love history. And so, you know, you just take, when you go to school, you know, you're lucky if you have a handful of master teachers or super teachers, and they're not always in the subject you end up doing. They just teach you the beauty of learning, the power of knowledge. And I had a number of teachers like that. After, you know, when I took my astronomy path, like many in my generation, I was inspired by Carl Sagan. I only met him a couple of times towards the end of his life. You know, he, of course, was the first iconic public astronomer who had a reputation, who, you know, he wrote Contact and then directed or helped produce the movie. And he was, but people forget, he was a top tier astronomer. He was the editor-in-chief of Icarus, the Planetary Science Journal, for a decade. You know, he wrote hundreds and hundreds of refereed articles. I mean, he was an absolute top tier research astronomer who had this light touch with conveying ideas. He was perfect for early television era. And yeah, he was inspirational because he told me that you could do that too. You know, you didn't have to just do your little research thing and write articles that were impenetrable for anyone else to read except your peers and colleagues. And then the other, you know, slightly less obvious role model in the same vein of showing that you didn't have to just do one thing or one flavor was Brian May, actually, who the lead guitarist of Queen, who's now, you know, he's had been knighted, or he's got high honors from the British government at this point. I sort of met him or encountered him when I was when I was a student in Imperial College in London, and he was a graduate student in the middle of an astronomy PhD. And so I only talked to him a couple of times, because when you're a first year undergrad and he's a grad student, you know, you're not in the same ballpark. But he was spectacular because he would come into the lounge at the undergraduate or the graduate lounge in optics, and he'd be wearing the leather gear, full top to bottom, the big hair. And he didn't look like the average astronomy grad student, put it that way. And me and my buddies in that same time frame, we went to see Queen on their sort of first tour, Hammersmith Odeon, you know, blew out my ears for a week, even though we were back in the nosebleed seats. And we looked at each other and said, I don't know if he's going to stick with astronomy. This Queen thing is going to be big, and it did, indeed, it was. But he did come back, and he didn't just get a pat on the back, a glad-handed PhD. He came back and he did the work, and he finished his PhD decades later. And he's now a great popularizer of astronomy in the UK. And of course, he's Guitar Magazine's top 5 guitarists of all time. So he's unassailable as a guitarist and as a musician. So that was inspirational, just to say, you don't just have to be one thing, or you could be two things that don't even seem like they would go together.
It's remarkable because, like you say, one gets tied up into that thing that you can only do this thing. But what's really fascinating, and it always brings a smile to me, how Carl Sagan truly inspired a generation of people to go into the career of astronomy. And it's just remarkable to hear. And it's wonderful in a way. I think the internet has made him back alive. Those of us that would have, well, you've actually had the honor to meet him, but myself through the series Cosmos, being inspired by him, it was just remarkable. And I mean, that was just fascinating, the story about Brian May. So I'm sure you are a Queen fan. That one is out of this world. Brian May, astrophysicist. Like you say, it's great inspiration for students that are listening to us, that you can, in a way, you can do it all, So that's wonderful. So somewhere along the way, you mentioned school, and of course, the influence of teachers. And what I found really remarkable is that, I mean, one sees you as a science person, astronomer, but you talked about the influence of literature and English and history. And I think that is so important to bring it all together. I read a little something about you, Chris, and maybe you can clarify for me. Did you really go to 11 schools?
Yes.
Is that an urban legend?
No, I counted them once. I always felt like a lot, like every year pretty much I seem to be changing. But, it was my parents got divorced and my mom remarried, and she married an advertising guy. But back then, that's when we moved from London to New York, and we just shuttled around. And he had this volatile career where he reached the peaks and the lows, and the peaks were amazing. So it was volatile because of my parents or my stepfather's meteoric rise and fall in career. So I was getting used to schools, and they were a mixed bag. I think I've sampled it all. I've been to a kind of hard knocks New York public school, which of course means, and I've been to a public school in the UK, which of course is the other end of the tier, because public school in the UK means very elite type school. So depending on our circumstances, our means, and where we live, I've sort of sampled all sorts, from sort of concrete jungle London school to elite prep school in the UK to whatever. I mean, it's okay. You sort of take what you can. You learn to be adaptable. You learn to be dropped into a strange situation, and just, maybe you don't end up with as many friends through childhood as you might. My first great and fast and forever friends happened when I went to college, actually.
It can be traumatic depending on how you handle it, but also it could be very enriching to have that range of experiences.
I almost forgot that the sort of low, you don't listen to the low points, you don't dwell on them, but I did for a year and a bit. I was sent to a boarding school in England, and I always, parents in the modern age, I tell them, don't do that to your kids. Don't send them to boarding schools. So this was a miserable place, truly miserable place. And it was so bad. I was 9, actually, away from my parents. They were on the other side of the Atlantic. And I ran away from that. I actually ran away from a boarding school at age 9, not really knowing where I'd go. So that, that was one of the low points, but it then makes a good story years later.
That would definitely have had quite an impact on you as a young boy to be in that environment. But here you are, certainly like a mentor and a hero to all of us, that what you've achieved. All right, so you've been engaged in a large amount of research, the number of publications that you've had, so it might be difficult to narrow down. What research that you've been engaged in that really has been like meaningful for you or stands out for you?
So I think a couple of projects that I did early in my career and then played out for a while were important to me because they were going in a slightly different direction. So I worked with a colleague, Greg Bothan, when we were both postdocs at Caltech, and kept it going as a faculty member. We decided that the galaxy population was not that well understood, that there are various selection effects and filters, observational filters, essentially on the galaxies we know. So we tend to see the brightest galaxies with the highest densities of stars, and a low surface brightness galaxy will fall below the sky brightness because the sky is not absolutely dark, as we know. And so we started to get into that and to deliberately survey for galaxies that just were inefficient in forming stars, or were very spread out, or for whatever reason were just low, diffuse essentially, and very low brightness. And they had been missing from surveys. So we found some, and some were spectacular, as massive and impressive as the Milky Way, but 100 times fainter in their appearance. So that was an important project because it was a major correction on surveys up to that point in galaxies. And then the other project, somewhat different and more in your vein, was when I got into blazars. So as a grad student, actually, as a young research student, I got intrigued by the idea of blazars or quasars with high polarization and variability. They're super active. They're possibly situations where you're looking down the throat of a black hole, a supermassive black hole that powers the beast. And so I started observing them in different ways, multi-wavelength, radio, X-ray, using the Hubble sometimes. And that was fun because that's just like exotic creature at the zoo. You're trying to study the most exotic creature at the zoo that gives you maybe an insight into the black hole and how it's fueled and so on. So that was fun. And it took me a lot of places. We had a portable instrument that we used to do this work, polarimetry, because it's a kind of a niche technique in astronomy. And we took our polarimeter everywhere. We took it to Chile. We put it on the 200-inch at Palomar. We put it on the 6-meter in Russia. So I've observed at the prime focus cage of the 6-meter in Crimea in the middle of the winter. That's a tale of hardship and endurance to be up in a prime focus cage when it's well below freezing for 13-hour nights. So some of the observing was interesting itself.
Okay, I can see you've had quite an adventurous life with regard to research. Yes, being in a cage at those temperatures. Well, many years ago, I was actually in Finland, and coming from the Caribbean, Trinidad, where our temperatures are like 32 degrees Celsius daily, and it was pretty cold. It was about 14 degrees, and I thought it was cold. But it was their summer, and I was like looking to see, hey, how can I put on the heat? And folks are like, no, it's summer, we don't put on the heat. So I could only imagine your experience. So we talked about all the telescopes, and you've even gotten observing time on Hubble along the way. But the big news recently, right now, has really been the images that have just been released from James Webb Space Telescope. So I'm sure you're all excited about it. So I have a question for you. First of all, your reaction to the images, and secondly, it's 5 they've released so far. Which one's your favorite, Chris?
Sure. I mean, it's spectacular. People were so nervous about this telescope. I mean, not everyone was being equally honest about how nervous they were, but it could have been an $11 billion pile of space junk, unserviceable by astronauts. And that would have been a nightmare for the subject, for NASA, for everything. So, it worked. I mean, kudos to the engineers. It's an engineering marvel, really, that it was so finely built and all the moving parts work. So that's always been fun. And it's, of course, been a long road. It was imagined 25 years ago when Hubble was barely up there, had been up only a few years. So it's been a really long slog. And it's very exciting locally because in my department, we have George and Marsha Reiki, who are PIs or co-PIs of 2 of the 4 instruments. So there's huge celebration here. We've been on top of it and hearing about it routinely. So it's wonderful, and it's going to do the first light experiment, the first galaxies, and which came first, stars or galaxies or black holes, or all 3 at the same time. How did they evolve together? That's great. And it will opportunistically do these exoplanet atmosphere sniffing experiments that are super exciting and could lead to the first detection of life beyond Earth in the next few years. Of the images they released yesterday, that's a hard call. I mean, as an extragalactic astronomer, of course, I love the deep field because it's a lensed image. It's interesting because the public, anyone can appreciate that image. It's powerful. And when you know that it's the size of a grain of sand held at arm's length, and there are thousands of galaxies in that image, you go, wow. So anyone can appreciate that. But then the power of science, the power of data, the power of astronomy is that if when you look at that image as an astronomer, and if you were to unpack all the information we can get or infer from that, the gravitational lensing, the evolution of galaxies, the constraints on the Big Bang, and so on, you unpacking that is a lot of information. It's a fantastic context for that beautiful image. And so it works both ways. It works as a beautiful image aesthetically on its own. You know, you can just say, wow. Or you can dig into the science you could get out of that image, and you could talk for hours about that. And they were probably going to take days and write dozens of papers on the deep fields, of course. So that's, I think, also a beauty of astronomy, that you can play both those levels of the subject. You don't have to understand how gravitational lensing works to enjoy that image.
When I looked at it, it was really mind-blowing, and it reminded you so much of when you saw the Hubble Deep Field, and now superseded by this. And as you say, the amount of science or simply the visual art to draw you into it, it's just amazing. So it's a whole new era opening up, right, Chris? That I always think of what Hubble images did for the general population. It excited the imagination. It also caused a little bit of disappointment when they would look through a real telescope, a small one. It's like, hey, isn't it supposed to look all beautiful like the images they were accustomed to seeing?
But Hubble established early on this process of, they made the beautiful images, the pillars of God and the deep field and so on. But they decided early on to try and make the colors astronomically meaningful. So they didn't just fake the colors. You know, NASA has, you know, every time when you look at talking about how disappointing things are through a telescope, when people first see the planets, the gas giants or whatever, through a small telescope, they're disappointed because they're used to these lurid reds and greens and yellows from NASA images, and they're totally fake. I mean, they just amp up the colors outrageously in the solar system. And the Hubble scientists said, no, we're not going to do that. We're going to make true color images, and we'll balance the colors, and we'll make them meaningful. You know, the green is telling you about where the oxygen is. The red is telling you about where the hydrogen is, and so on. And they did that throughout the Hubble project, which I think is admirable. Now with James Webb, it's tricky because the public sort of forgets that you can't see this radiation. It's invisible. All of it is false color. It's you know, and you have to, that's another part of the unpacking you have to do with the public when you're telling them about these images. No, you can't actually see this. This is not what it really looks like.
Yeah, it's a good thing to remember. One does forget being in the infrared. It's actually all invisible to our eyes, but here we can create what it is. Fantastic. So, Chris, you have excelled in research as well as teaching, as I mentioned when I introduced you. And it turns out that you've taught astronomy to the monks in Tibet. That sounds so interesting. Tell us a little bit about that experience.
I mean, it for the first few years, it was just to monks, and now in an appropriate manner, nuns are now included in the program. So I taught nuns and monks, Tibetan, in exile. They're all in exile, of course, because they live in India. So it was a fun thing because I got a call out of the blue. Someone had heard of that I was a good teacher or whatever. And so word of mouth led the young head of the Science for Monks and Nuns program to just call me out of the blue and say, how'd you like to go to India to teach the Dalai Lama's monks cosmology? And it's not a question you ruminate over. You just say, sure, and then you figure it out. So it came out of the blue. I went in 2008 for the first time. I've been 8 times maybe since. And for the experience, it's incredible. One of the books I wrote, Humble Before the Void, was from the first time I went there, because I knew as I went, this is amazing. I have to take notes or keep a journal. So it's usually in northern India, Dharamsala, the government in exile of Tibet. But since then, I've taught in southern India and all around India, where the great monasteries and nunneries are for the Tibetans in exile. And it's a really interesting program. The Dalai Lama, to his credit, decided that the monastic tradition for Buddhists was kind of old-fashioned. It was great on teaching them rhetoric and philosophy and comparative religion, but there was no math or science. And he, as a very forward-thinking person, very interested in science, he's dialogued with scientists for decades, said, no, we need math and science. They're not prepared for the 21st century if that's not in their curriculum. And so they had to import people. Now they're going to have homegrown in the future, I hope. But they started to import people like me and others to teach biology and neuroscience and other topics. And we just go out and teach in these workshops for 3 or 4 weeks at a time, a few dozen monks and nuns in pretty rudimentary conditions, almost off the grid. You know, you might not have internet, you might not have heat, the lights could go out at any time. So you can't rely on your high-tech teaching tools, you have to make do. And that's a good discipline for me as a teacher, to learn how to teach very simply with minimal materials. But it's a singular experience because the students are so special. I mean, they range in age from low 20s to 40s and 50s, even some are quite senior, like Geshe's. And they're all mixed in the classroom, the nuns and the monks, different ages, but they're absolutely on point about learning. They're super curious, they're super attentive. They bring to the table their rich cultural experience and their different religion. And so in the margins and at the edges and in the evenings and at tea time and whatever, we're talking about religion and philosophy and all sorts of things. So it's an amazingly rich experience. And I guess I would compliment them by saying they are the most pure learners I've ever had. You know, they're doing it for all the right reasons. Their stamina is incredible because we are a long time in the classroom, we have evening sessions, but they probably have got up to pray at 4 or 5 in the morning before the sun comes up, and they'll have to do some stuff later in the evening. And they're indefatigable, they just keep going. But it's a lightness too. They're very light in their approach to things. Just always laughter in the classroom. They're always joking. They're, you know, making fun, pranking people, and so on. They're just wonderful to work with. So I just can't wait to go back.
Did you find at any point that there was a conflict with their worldview and the scientific perspective, or it was all philosophical?
No, actually, for astronomy, no. I mean, my colleagues who taught biology will have known that, you know, they have some in Buddhist training of some kinds. They're not very modern ideas about biology and living organisms. So there's more dissonance there. But in the realm of cosmology and philosophy, the ideas, it was interesting. There was almost no point at which there was anything in their training that would lead them to question or have any problem with what I was teaching. And that would extend to, you know, the multiverse, the idea that there are many universes, because their tradition encompasses vast timescales. The longest timescale that's written in Buddhism is 1 trillion years, which is the luminous time frame of the universe before all the stars die. They contemplate multiverses, the universes coming and going in a cyclic but very long fashion. They contemplate life forms on other planets and stars that are maybe more advanced than us and not like us at all. So their astrobiology fits totally into their perspective. So interestingly, there was nothing in cosmology that was dissonant with their training or their perception. They were open to it.
That's quite amazing. As you said, the concepts of multiverse, even life in the universe coming in philosophically that way. It's amazing stuff. I can talk to you for hours, Chris, but I have a few things I do want to cover. And so I'm going to pick on your brains a little bit and get to know you better as a person. So share a thought or idea that blows you away.
Well, I mean, as a cosmologist or extragalactic astronomer, the idea that still blows me away is quantum genesis. The idea that if inflation is correct as a modification of the standard Big Bang model, that the entire universe was potentially a quantum entity, and that, you know, and that speckles, the bumps and lumps you see in the microwave background, are quantum fluctuations magnified to the size of the seeds for galaxies to subsequently form. That is an inevitable consequence of the inflationary cosmology, and it's an extraordinary inference. It's not fully confirmed. Of course, inflation is not verified beyond any reasonable doubt, but it's extraordinary to think about it. And it, of course, opens up, as you know, it opens up the possibility of the multiverse, because you could have, if you had a quantum seed, why not other quantum seeds? And the laws of physics would be randomly different in those different realizations of space and time. So it sort of, you know, it kicks into modern astrophysics, this extraordinary, almost science fictional notion. And yet we could be on the edge of showing that it's correct.
Okay, so just bouncing off that same thought, is there something you wish you could know now But we don't know. We don't know for a fact. I mean, as we look back in the past decades, there were things that we didn't know that have been confirmed. But as we stand here in the 2020s,
Yeah, I'm impatient to know what dark energy is. I mean, I believe the observations that show we live in an accelerating universe. Like, obviously, there was a Nobel Prize awarded for that a while ago, but that has not informed us as to what is causing the universe to accelerate. And the progress on that has actually been kind of halting and rather slow. It's just a very difficult problem. So I'd love to fast forward and find out what dark energy is. And maybe beyond that, another issue that is also swirling around us in astronomy is, the modern cosmology, the Big Bang cosmology, with major ingredients of dark energy and dark matter, seems fairly sturdy. It seems fairly robust, but there are flaws or flies in the ointment at the moment, tensions observationally, because the data is getting so good. And I would like to, and there's two schools of thought. Some just say they're just flies in the ointment. The data will get better. These tensions will go away. The mismatch between theory and observation or simple models will go away. And another school says, no, these are deep flaws. These are fundamental flaws, and the whole thing may come crashing down, and we may just have the wrong paradigm. And I don't really subscribe to that yet. I'm a little cautious, so don't want to go there. But I would love to be able to fast forward and find out if we've just all got it wrong, and there's some major, huge paradigm shift approaching in cosmology, which would be exciting, of course.
yes, absolutely. There's always so much to learn and to know. So a few more other questions I have for you. As an author yourself, what is your favorite book? And I'll throw in a movie into that. What's one of your favorite movies?
Sure. Well, the book, when I read it when I was probably in college, I guess, that blew me away and just showed me the power of writing in different ways was this famous book, 100 Years of Solitude, Gabriel Garcia Marquez. So, it's magical realism, and he's obviously an incredible author at the height of his powers. You credit the translator, Gregory Rabassa. They don't always get enough credit because it's exquisitely translated into English from Spanish. So that book just blew me away. It was like, wow, I couldn't understand how someone could write that eloquently and beautifully and conjure up all these worlds and so on. And then the other book that is a little more obscure, but it appealed to me as a scientist, was called Time's Arrow by Martin Amis. Not as well known. Martin Amis is a very well-known English writer. He's done a lot of good stuff. Time's Arrow is a small book, and it's a set piece. It's almost an intellectual exercise. It's a book written in reverse chronology. Not backwards writing, but just the items. It's a small book. It's a technical tour de force because he writes a story that somehow makes logical sense told backward. And then there's a layer of the story that's about the Holocaust. And so there's a real tension as a sort of emotional tension in the subject matter he's talking about. So it's an incredible book. I was blown away by that. Just at a technical level, I thought, oh, how could somebody write a book that's so clever and so well executed? Movies, I don't know, that's hard. I love movies. I watch lots of movies. I mean, I probably just pick a couple of random movies. I couldn't even make a top 10. I, like a lot of other people, because it's had its 50-year anniversary or something, I'm a fan of The Godfather. I loved that movie when it came out. It was metaphorical for I'm an immigrant to the United States and naturalized American citizen. It was so resonant about the immigrant experience. It prefigured all these other, uses of the mob and mafia, some done lightly, some done not as well. And it's just a masterwork of filmmaking. And of course, incredible actors early in their careers and at the height of their powers. And then more recently, and also resonating with sort of philosophical and science ideas, I like Truman Show. I thought that was a great movie. Just the idea that, you might be living in a bubble world and being observed and so on. And Jim Carrey was at his best, of course, and it was very well directed and put together. So those are two movies I would but there's
Yeah, certainly great books and great movies. So if anyone is looking for titles to read, definitely. I mean, 100 Years of Solitude and Time's Arrow is definitely something to look up as well. I thoroughly enjoyed Truman's Show also. And you're right, there's a whole philosophical thing with it in terms of how we believe the lives we live and what reality is and what it really is. I mentioned briefly that you and I did meet in Trinidad some time ago. So when you were here in Trinidad, do you recall what's one of the interesting things that you may remember from your trip?
Oh yes, I mean a few things. Well, I truly enjoyed that dinner we had in the yacht club. That I remember that very well. That was just such a beautiful evening, and the food was wonderful. We were there for Carnival, and that was amazing, of course. So that was a highlight. I mean, a kind of obvious highlight because it's a centerpiece of the year, and there's so many the costumes and the food and the dancing, and it's so amazing. But actually, the quieter special moment that Dinah and I both remember is when we took a few days and we went to the north side of the island, and we stayed in a little house on the beach. And that was just amazing. It was so tranquil. It was so lush. The beach was amazing. It was a small town. We walked through a small town. We saw some amazing ceremonies. There were just some dances and some ceremonies happening. We walked into almost the rainforest there, and we found people who were living there, like off the grid, in tree houses almost. And it was like encountering a different part of the island, and that was wonderful. And I have to add a fourth experience because, with me and Dinah, I usually get the short straw when it comes to driving in a foreign country. Driving in Trinidad, that's a trip.
Trip, literally. We will vouch for that. So, all right. So before I release you, Chris, one or two things I do still want to hear from you. So, I know you are currently authoring a book on exoplanets and life in the universe. So, not that it's to be a spoiler, but do you believe that there's intelligent life out there?
I'm just not clear on that. Do I believe there's life out there? Yes, absolutely. I think the odds that there are, we essentially know there are billions of habitable worlds in the Milky Way. Just formally habitable. Water could be liquid on the surface of a terrestrial planet. The odds that they're all dead, biologically dead, are very low. So I think there are microbes all over the place, not like ours, different forms of biology even. The intelligent life thing is tricky because, our example tells us there were hundreds of millions of species of life on Earth, and only a handful became intelligent, and it took 4 billion years. So it may be very hard. So, you can't make a logical argument with a sample of one. You're not allowed to use your own example to make a scientific argument. So I tend to be pessimistic. I don't know why people use that word, but they do, that there's a lot of intelligent life. And if there's not much, then the distances and the time gaps for communication are so large that operationally we're alone. So I would say that's what I feel as a scientist is the most likely scenario, that we're operationally isolated in time and space and alone. Apart from the fact that the communication issue is so dramatic, I think it's also likely that if there is intelligent life out there, it's either unrecognizable, undecipherable, or inscrutable, any of those words. The anthropocentric tropes of science fiction, where they're always sort of humanoids with just bad skin conditions, but otherwise they look like us. That's just a conceit. That's anthropocentric thinking. So I tend to believe that if there's intelligent entities out there, they could be wildly different from us at the level where we couldn't communicate. We can't even speak to creatures who share 98% of our DNA on the Earth. So, what are the odds of communicating with aliens of unknown function and form?
Very, very important points you have raised there. Absolutely. And again, I guess the bad influence of the movies, my favorite Martian, and we think Martians are green, the aliens have big eyes, and it really gets into your psyche and the children's psyche. But as you say, scientifically, they could be wildly different. So on the Wormhole, we have a few signature questions we ask all our guests. And one of it is that if you could, in a magical world, be any animal you could choose to be, what would it be?
I think I live in the desert, and some of the we have rich wildlife and animals. The animal I've observed and wish I could be is a hawk, because they're so beautifully tuned to their environment. Just the idea of sailing on the wind and the thermals and flying and being so good at what you do that you can spot prey 100 meters below you and in a few seconds dive down and catch that prey. We don't see hungry hawks here. We don't see hawks that don't know how to survive. So it feels like they're way near the top of the food chain, and they have a pretty amazing life looking down on the earth. So I would do that.
Okay, a hawk, certainly. Yes, it is absolutely a fascinating bird. All right, so last question, and a big one at that, big and small. What's your message to the world?
Wow, message to the world. Well, I mean, in a trivial one would be look up, because I want more people looking up. I want more people. We're losing our dark skies, of course. We live in cities and light pollution is becoming omnipresent. When I poll my students in a big class and ask how many of you have ever seen the Milky Way, it's less than 10%. It's almost nobody. I mean, that's sad, So that simple message would be just look up, appreciate what it is that we have that's available to us, that's inspiring, with the James Webb images as extreme examples, but you can still enjoy it as a naked eye observer. And then the message, more large than that, or what I could change if I could change the world, would be just to somehow make it so that worldwide education was universally available and equitable, because we know that education is the key to so many things, that literacy is the key to advancement, and especially for women in developing countries, it makes a huge difference in outcomes. So, as an educator, I know that education is unevenly implemented around the world, and that's a shame. That's sad, because it's so important. And in the end, it's not even that hard or expensive to do universal education and to put some resources into teachers. My son did his master's degree in education in Finland. We were talking about Finland, and he'd been there just a few weeks when he just said, in sort of on a Zoom with him, he said in amazed voice, he said, "Wow, do you know in Finland they pay their teachers as much as lawyers and doctors?" I was thinking, yes, because they value education.
Those are very, very powerful messages, Chris, that you shared with us. And I love the brevity and the depth of the first one. Look up, and the immensity of the universe. And then you really got me emotional with your second message to the world about universal education for all, and how that alone, the change that it can create. And as you've shared that story about your son, several of our collaborators are in Finland, and I too was amazed to learn that I think a professor's salary is just perhaps a little bit more than a bus driver. So it's a fascinating society, and what they're able to achieve. Chris, I could go on and on, but I am going to release you now and give you a heartfelt thank you from us at the Wormhole for taking the time to have this conversation with us. And thank you so much for joining us today.
Oh, it's been a great pleasure, Sharon, and I hope we meet again face to face before too long. So
I certainly look forward to that. Yes, and enjoy some more carnival and some local cuisine and everything, and the beaches, of course. So, folks, with that, it's a wrap from us here at the Wormhole. This is me, your host, Sharon Hack, signing off from none other than Studio 42, where we seek to find the answers to life, the universe, and everything. Bye.